Okay, so we've been practicing that probability is always want over total. But when the number we want and the number total happen to be permutations or combinations, then we've moved into the realm of level 2. So let's try some examples so we can remember how this works. Okay, so suppose we had a bowl of candies in which 3 are green, 5 are yellow, 7 are red, and 6 are purple. How many groups of 5 candies can be made? Well, first we have to know our total, don't we? Let's see. 3 plus 5 is 8, plus 7 is 15, plus 6 more, so that's 21. Okay, so how many groups of 5 candies can be made? That's a group, so that's a combination. So we would need to do 21C5, and that is 20,349 different groups of 5 candies of mixed colors. Okay, so how many groups of 5 red candies can be made? Well, if we want them all to be red, we can only pick from the red. There's only 7 red. It's still a group, so still a combination. So 7C5, which is 21. So there's a lot fewer groups of 5 red candies than there are groups of 5 mixed candies. So here we go. The probability that we get 5 red candies is want over total because it's probability. There's 21 groups with 5 red candies, and there's total 20,349 groups of 5. So that's our probability. Checking to see if that simplifies in my calculator, and it does. That becomes 1 over 969. Okay, so using that same group of candies from the other page, remember groups of 5 was 21C5, which was 20,349. So now let's set up a different question. How many groups are there with 2 green and 3 purple? Well, it's still groups. So we have to do combinations again, but this time we'll have to do 2 combinations, 1 for each color. So if we want to guarantee we get 2 green, we have to pick that only from the 3 green, so 3C2. And, remember and means multiply, we have to get 3 purple to make our group of 5. So to get 3 purple, we pick from the 6 that are there. So 6C3. Okay, so 3C2 is 3 times 6C3 is 20. So 3 times 20 is 60 different groups. Okay, so the probability that we get a group of 5 that has 2 green and 3 purple, want over total, is 60 groups with 2 green and 3 purple over all groups, mixed colors, in any set of numbers, any colors, any numbers of that color, 20,349. Okay, checking to see if that simplifies. It does. It becomes 20 over 6,783. Okay, so what if we had a deck of cards? Remember, a deck of cards contains 52 cards, 13 of each type of card. Each suit. Those are called suits. Remember, there's 4 suits: spades, hearts, diamonds, and clubs. So how many 7 card hands are possible? Well, if there's 52 cards total, hands of cards are always combinations, so that would be 52C7, which is a large number. 1, 3, 3, 7, 8, 4, 5, 6, 0. 133 million. All right. How many of those 7 card hands have 2 spades, 2 hearts, and 3 diamonds? Well, that's going to be a lot more specific, so that's going to be a lot smaller number. So, if we want to make sure we have 2 spades, we can only pick from the 13 spades. So we'll have 13C2. And if we want to make sure we have 2 hearts, we can only pick from the 13 hearts. So that's another 13C2. And get our 3 diamonds, we can only pick from the diamonds, so that's going to be a 13C3. And since it's and, we're going to get all of these things, we're going to multiply them together. Okay, so that's going to be 78 times, same answer here, 78 times 286. Which is 1,700,000. Oh, 1,740,024. So the probability of getting 2 spades, 2 hearts, and 3 diamonds is 1,740,024 over the total, which is that 133,784,560 7-card hands. I sure hope that simplifies. Let's find out. The calculator does not like that size of a fraction. It just gives me a decimal. My probability is 0.013. So a very small probability. That's less, just slightly over 1%.